Hey folks, in this video we're going to look at how to write a CER, that is Claim Evidence Reasoning. In science we have this requirement that any claims that we make be backed up by evidence and sound reasoning. So we would never make some bold new claim in science without also specifying here's the data to back it up and here's my thinking and how I interpret this data. So when we did our evolution unit, for example, we would sometimes make a claim like this species and that one have some common ancestor. So then we would need to cite what our data was on this. Maybe we have fossil records showing that ancestors of each of these species get closer and closer in appearance over time as we get back further and further in time, rather. And so we find eventually that we only can find a single type of fossil, and it sort of looks like one species and sort of like the other. Or we might look at something like homologous structures, vestigial structures, comparative embryology to back up that argument. No matter what our evidence is, it's important that we have evidence, and the evidence needs to be reliable. One mark of that is that it's widely agreed upon as being reliable. So we don't have one group getting one result and a different group getting a different result and a third group getting a third result. If it's reliable evidence, we should all be able to agree on the evidence pieces. So we'll look for reliable evidence. The next piece then is reasoning. How am I thinking about that evidence in order to make this claim that I'm making? Now, we want to keep in mind with CER, we do claim evidence reasoning in that order only for writing it. That would be a terrible order to think about this because we're trying to make a claim before we have any evidence to back it up. So then it just becomes a game of trying to find the one piece of evidence that supports our original idea and ignoring anything else. So we want to switch up the order when we're thinking about this. We're going to do ERC, Evidence Reasoning Claim, when we're thinking through these. So as an example, I have some global temperature data shown here for the last 30 years or so. And we're looking at data from a few different sources. We can see some agreement there, so that's evidence that we have some reliable evidence. We have a general trend that maybe is apparent here, but we also have lots of little wiggles all the way throughout. So we're going to need to kind of decide how we can interpret this. What claims can we make based on this data? So first off, interpreting this, we have all these different lines. Those represent just the different sources of this information. And when we track those different lines, we see they're mostly in very close agreement. Over on this side, we have annual average global temperature anomaly. So the idea behind that is that we take some average value for global temperature over this whole time period, or rather over some other time period relative to the January 1951 to December 1980 average is what we're basing this on. And we're going to make a claim based on this evidence. So all of that, all this data is relative to that average temperature. So 0 would mean that temperature is exactly at the average temperature for 1951 and 1980. So that's our 0 meaning on this. All right. So next, let's go through our evidence. So as I mentioned, there's a lot going on here. We have a lot of little fluctuations, up and down wiggles. And then we have some kind of overarching trends on this. Now, we might expect to see global average temperature changing if you think about something like seasons, maybe at the surface. So maybe these big wiggles that we're seeing are just summer, winter, and like that. So let's analyze this first to see if that makes some sense. So let's look at this section right here. I see a high point like summer, a low point like winter, a high point like summer, a low point like winter. And maybe that makes some sense then. Summer, winter, until we look at the time frame for that. Well, we have 1980 to 1985. So if we interpreted it that way, that would indicate that there were only 2 summers and 2 winters in that whole 5-year period. So that doesn't make any sense. The other reason that doesn't make any sense is because there is no global summer or global winter. right? They're switched. So the northern and southern hemisphere are switched. When the northern has summer, the southern has winter, and vice versa. So that isn't a useful way of analyzing this. We can't make any claims based on that. That's a bad analysis. So let's see what else we can come up with here. Since those little wiggles aren't summer, winter, summer, winter, I don't have information in front of me that would suggest what is causing that, and it's not standing out as a real obvious thing to me. So, maybe let's instead focus on some other aspect, something aside from the little fluctuations there. Let's look at kind of where those fluctuations center around and how that center shifts over time. So I'm just going to add some marks now to indicate where we have maybe the midpoint. Think of the midpoint of these fluctuations. So I'd see like here's a midpoint between a high and a low. Here's another midpoint, and here's one. I'll just kind of mark the middle of these fluctuations. Whenever I see one that stands out here, just going to go for the middle. Oh, here's a big jump there. Another one, okay, here, and then, some littler fluctuations here. Okay, some jumps around a little bit, a drop, okay, and then back up a little bit, down a little bit. Okay, so I see kind of a general trend, roughly this direction. Maybe it's more of a curve shape like that. It's a little tough to tell. One thing we can see is that we end quite a bit higher than we start out, but what does quite a bit mean here? I've got half of my graph space there, but we need to look at the scale to decide, is this a meaningful change in temperature? Now, looking at the scale on this side, start out with our middle around there, and then end up here-ish at the end. Oops, sorry, that's in the wrong section. There we go. Okay. So it looks like the middle of our fluctuations has gone up over time and pretty steadily. We had a couple little drops in there, but mostly we've had an upward trend from somewhere between 0.1 and 0.2 to somewhere between 0.5 and 0.6, it looks like. So, maybe 0.5 degrees. Now, that's a global average over a large number of sites, land and ocean, and the whole global temperature has changed by 0.5 degrees. That doesn't seem like a whole lot, but I do remember hearing on the news about people being concerned, scientists being concerned about a change as small as just a few degrees Celsius. So, 0.5 degrees, maybe that is a significant amount there. The other thing I notice on this is that, remember, 0 means the average here, the average from 1951 to 1980. And so I don't have the data from 1951 to 1980 shown on this graph, but I do know a little bit about that data would have had an average that's down here at 0. So if we mark this off, that's the average during that 30-year period. And then our current 30-year period, the 1980 to 2015 almost, 2013 I guess, that's all higher than the previous 30-year period. So not only has temperature gone up by at least a bit in this 30-year period, the 1980 to 2013, but it's also all higher than the previous 30-year period. So this 30-year chunk is higher than this 30-year chunk. Those two together suggest to me that temperature is increasing on a global scale. Temperatures are increasing according to this data. So we've kind of thought through the information and how we want to interpret it. Let's go ahead and write out our claim, evidence, and reasoning. So the claim that we're going to make here is that global temperatures are rising. Okay. The evidence that we pointed out here. So two big things that we were focusing on. First off, during the period from 1980 to 2013, we see temperatures change from around 0.15, and that's Celsius, degrees Celsius, to around 0.55 degrees Celsius. The other piece that we noticed here is that all temperatures, every single one, there isn't anything that that defies this. Now, maybe a little tiny bit right here. Okay, I guess that does cross back down just a tiny bit, but almost all, we'll say. Nearly all temperatures recorded in that period are higher than the 1951 to 1980 average temperature. Okay, so our reasoning on this, we're trying to connect what we see on the graph to this claim that global temperatures are rising. So, from the data on the graph, it is clear that although temperature fluctuates, the average temperature has an increasing trend from 1980 to 2013. Oops. 2013, there we go. Oh my. 2013, there. Got it. Okay. Also, nearly every data point on the graph happens above the level of the average temperature from the previous 30 years. Therefore, I don't remember if there's an E there. I think there is. Okay. All right. Therefore, global temperature has increased, maybe not steadily, but has increased over the last, we'll say, we have some evidence to say over the last 60 years, or at least that the average over a 30-year chunk there and a 30-year chunk more recently has increased. So global temperature has increased over the last 60 years. So from those two bits of information, we can tell that that's true. So just kind of an overview here. We thought through the evidence first. We noticed the fluctuations, but the general increasing trend. We also noticed that everything was above zero, where zero means the average temperature from 1951 to 1980. So those two pieces of information show a general upward trend during the last 30 years, and also that the last 30 years on average are higher than the previous 30 years on average. And let's see, I'm going to add that. The last 30 years have a higher average temperature than the previous 30 years. Okay. So therefore, in the last 60 years, we've seen an increase in temperature. So that gets us to our claim that global temperatures are rising. So our evidence is kind of the beginning point. The claim is the ending point. The reasoning is the bridge between those two. How do we get from the raw data to our final claim on this? Now, this data certainly could be used to make other claims, and you could get more specific. Maybe you would focus, maybe have some more background information on what's causing those little fluctuations and focus on that. Maybe we would look at something like those differences that we see in the data, small though they may be, what's causing those differences. Can we track down that cause and see what's different about the data collection method or locations, or what's different there? So we could make a number of different claims for any set of evidence, any collection of evidence, and use that for our CER. This is maybe not something that scientists typically write out in this format, but all scientific writing is done using exactly the same thinking. Here's my idea, here's the evidence that I started with, and here's the thinking that I went through to get to that final idea. And it's a little bit backward, it's not chronological. It's sort of getting to the good part right away so that you might read through the more technical aspects of this, I think. The claim ends up being sort of your hook if you're thinking about writing in an English class, even though it comes last in our thought process. So that's a CER. We're going to be doing these a few times throughout the rest of the year. This is a really important skill in all sciences, not just in your 8th grade science class, but you'll be seeing this in all your science classes going forward. And so it definitely is to your advantage to get good at these. We'll practice quite a bit. Thanks very much for watching, everybody.